All right, so we've covered a lot of information this morning already, just in terms of getting set up and getting an orientation. This is more crisp now as we walk through and see what the objectives are. So we've got database client server architecture. There's basics on that. There's terminologies like session and transaction that come into play with this client server architecture. I mentioned already this entity relationship diagram. We'll walk through what that looks like and doing it. That's the underpinning of expressing essentially the blueprint. You think of a floor plan for a building. You know, the ERD is the blueprint for what the business analyst is wanting to communicate to development. So there's this conceptual perspective of, hey, this is what the customer needs. And the receiving party, meaning development, will take that and turn it into a logical entity relationship diagram, adding more detail and whatnot. All right, so this is a really, really important piece of the puzzle. It doesn't take a long time to go over it, but it's really critical in the overall flow. You know, if you put on your resume that you understand any relationship diagrams, that's a big plus. Like, oh, okay, this person can read these things and know what they mean and how to use them and how to develop them. Okay, so there's some really good questions to work around that are covered in this class.
Just as a general style, will you kind of point out things that you think may or may not be on the exam or the certification?
I do that with Agile a lot, with PMP. For the Oracle SQL, it's anything's fair game.
Okay.
So it's like everything you see that's written in SQL,
Okay.
you know, I will mention items about how it will appear on the exam, but you can pretty much assume anything you see in SQL is going to be on the exam.
Okay.
There's a couple minor exceptions to that statement. I'll point those out as we go. So just take that assumption. Everything you see in SQL is going to be on the exam, including ERD. You know, that's going to be out there because that's the gateway into the structure of the data against which you're going to submit queries. So there may be a question or two on ERD. There's not going to be a lot. Okay, SQL itself is ANSI, American National Standards Institute, so it is a standard. The standard, like every standard, keeps developing. Like every standard, it's a conglomeration of two competing ideas. So, you know, competing ideas meaning that the best example is joins. You're joining data from two different tables because you want to physically generate a report that has like names of departments and the names of the employees in that department. Those come from two tables. You got to do a join to bring those together visually on a report. Okay, there's two different ways of doing joins. You know, Oracle had their approach, which is like, yeah, a little innocuous, kind of more like algebra. And then ANSI SQL doesn't necessarily include that, though since Oracle is the one providing the certification, it's on the exam potentially. But there is another join on where you literally use the word join and literally use the word on. So these variances will bump into, but really, truthfully, that's the only major variance. A few others, but that's the major one. All right, SQL Developer, IDE, I mentioned that earlier. What does IDE stand for? Or if you've been exposed to the term already.
Integrated developer environment. No?
Right, integrated development environment. So all that means is that instead of like in one window, you're writing text files that are the code, and then in another window, you're running code and debugging, and then another window, you're doing whatever. All of those different activities are put together in panels within one window. So instead of having like 4 or 5 windows, you got one window, but inside that one window, there's multiple panels. So you'll see that with SQL Developer. We've already brought up SQL Developer, and you're seeing these panels straight out. All right, so this idea of an IDE is foundational. Every developer works in the context of an IDE these days. So you have to be comfortable with it. If you're managing or if you're in a software environment, every project the engineers are going to use one of 2 or 3 or 4 IDEs. It's not like there's the right IDE. You could have the same projects, meaning same programming language, same technologies, whatever. And you know, one group of developers may prefer using something called Atom, ATOM. Others may prefer using some other IDE. They may using two of them, like SQL Developer and a different IDE. Sublime is another one that's out there. Python. And a lot of these IDEs are configurable to any one of multiple languages. So the IDE environment is very rich. Okay, so just go with your wherever the projects are. You want to keep the abstract notion of IDE in your forefront because you can ask relevant questions about what languages are you using inside your IDE. That question makes sense. Okay, like what languages are you using inside your IDE? Are you able to set breakpoints in your IDE? That allows you to step through that allows developers to step through their code very precisely, efficiently, and quickly. Okay, so get comfortable with IDE and a relationship diagram. Get comfortable with IDE. Okay, from the perspective of this course, it's very hands-on. So I mentioned you can copy and paste, but really want to emphasize it's a lot better to type it. It's the typing is is engaging your mechanical memory. You'll just remember a lot easier on the exam when you let the learning experience pass through your mechanical memory of having to type stuff in, seeing the error message that said you did it wrong. You gotta go, oh, what did I do wrong? You need that experience to really get that. Otherwise, you're not going to pass the test. So in other words, I'm saying, don't bother doing the certification exam if you're going to copy and paste. It won't work. Okay, you just want to get the feel of SQL, and then you can not take the certification exam. That's legitimate. If that's your objective, copy and paste to your heart's content. That's fine. All right, so we'll be using a simple online bookstore project. It has 4 tables in it. We'll be adding another table at the end of it, so technically it's like 5 tables, just to show some of the more complex SQL. Prep here, I'd mentioned this earlier. As we go through the class, a lot of this is like, okay, here's what to do, here's how to do it. Okay, and then we stop and we have quizzes. So there's a 3 or 4 slides that will focus on like, okay, we did the intro, now let's do a quiz. And it takes about an hour, maybe 2 hours to go through the quiz stuff and the answers and whatnot. And we do that with the bookstore as well. It's like, okay, we did it. Now here's some slides that have a bunch of questions on them. Let's go through and do the questions. So that gives you an opportunity to do it on your own. But the real venture that's best is do your own project. Take the concepts from the class, do your own project. The book that we provide is listed here on the second to the last bullet. And we've got the online practice exam, which I showed you as far as the login credentials earlier. So objective, style, that's what we're getting into. Okay, with regard to the certifications, this class focuses on Oracle Database SQL. OCA is Oracle Certified Associate. Okay, and the book title has the name of the exam in it. For those that are in the room, they've got that. Okay. If you're going into these other areas, number 2, number 3, or number 4, there's additional exams that's outside of this, but this is out here just so you can see, okay, what are the certification exams? We only focus on number 1 in that left corner here.
Dan,
Yeah.
a question. So here's Oracle, number 3, Oracle Database 12c administration. 11G. I thought you said the latest is 18c. So it's just used as example.
Yeah. Okay, so this takes us into the Oracle's versioning. Okay, 18c is actually 12c.
Oh, okay.
So
12c.
so Oracle changed their release nomenclature, the release naming convention, I should say, recently. So they basically brought everything up to 12c, and then I forget what year they did that in. It's like 3 years ago, so like 2016 or something like that. So after that, now they call it, they would have like 17c, 18c, this year will be 19c, next year will be 20c.
With the same version, just called different names?
They do an update each year, but they made some huge changes in Oracle 12c.
Okay.
Some major architectural structural changes.
Okay.
So that they introduced this concept of a pluggable database. So you could have an Oracle installation under one database server in a company, and then a separate Oracle database installation under another server. They have this concept that the database servers are what they call multi-tenant. Think of a tenant in an apartment building. Multi-tenant databases. So the tenants are these pluggable databases, or called container databases. So you can take an entire database and move it like detach from database server 1 and go attach it to database server 2. Okay, so that had a huge impact on various features, like how do we do user account tracking, because the login has to follow the database. All right, so they've added quite a bit of sophistication in terms of just managing the basic architecture of databases, so that the database is no longer monolithic. It's extractable components that are be plugged in under another database server and still operate.
Okay.
I have a question. So our exam certified is only number 1.
Correct.
So about 2, 3, 4, we don't need to study on that?
Correct.
Because on my TRA, they mention about the 12C.
They'll mention 12c as a matter of convenience, because 18c is really 12c.
Okay, so 12C, it means correlate to Oracle database.
Right. Yeah, this number 1 here is an exam from Oracle that they validated on the 11G database and on the 12C I think they'd say they validated on the 12C database. The 12C database is essentially 18C as well. Because we're in this period of time for about 5 years where people are getting accustomed to their new release naming convention. All right, so that's a backdrop on Oracle for certification and version numbers. All right, so SQL and RDBMS. So RDBMS is Relational Database Management Systems. That's this top bullet here. That name is mentioned, so you don't have to write it down, just point to it if you want. Relational Database Management Systems means I've got a server, I've got schema that has to be created for that server, I've got users that have to be maintained from a credentials perspective. Okay, so and I've got backup and recovery that needs to be handled. So when it talks about database management system, it's much more than just the database and accessing the data. It's like, how do we do recovery, for disaster, even to the extent of disaster recovery, or maybe online hot recovery. So there's various architectures involved with the RDBMS. So we'll just be focusing on the SQL, which does not include the DBA administrative functions. Okay, the DBA administrative functions are a completely separate category of commands and tools. And those commands and tools are specific to like Progress as a database, Access as a database, Oracle as a database. Those commands and tools are not standard. All right, basics: adding data to a table, selecting data from tables, updating and deleting data in tables. All right, that's what we expect. All right, that's what this is all about. So, question: what is a table? When it says table right here,
It's a place to store data.
Rows and columns and data.
exactly.
Two-dimensional.
It's a two-dimensional grid of
Stored
rows
data.
and columns. And you may want to think of it more as, from a definition perspective, it's a two-dimensional table of columns. It could have 0 rows in it, or it could have 10 million rows in it. So that there is no labeling on the rows. The labels are only on the columns. That's a key thing to keep in mind, because that's a pure data. So if some of you are getting into a company that's big data oriented in analytics, that same definition of the table that's used in an RDBMS, that is the same definition of a data set. There's no difference between a true table and a true data set. There's absolutely no difference whatsoever. The complexity and nature of the data in a big data set may not fit into the structure of a relational database. Because big data is like everything you can possibly analyze or take in as input, and then process, transform using, and it's Christine or Christina?
Christine.
Christine. Using, as Christine just eloquently stated, she used the word transformation. That's a really key word. You take data in, you transform it, and you have some results. Okay, so in the big data arena, the structure, the very strict structuring of SQL is supported, and the semi-structured formats of like JSON or XML or some of these, or just simple things like comma separated version, tab separated version, whatever. There's a lot of different formats in addition to standard tables that are supported. So think of the relational database tables as being a subset of the big data, but fully supported in big data. Okay, so other items in here. We've got some terminology here introduced under RDBMS. Right. The last phrase in this bullet is database instance. You want to underline that? That's really common terminology. A database instance is a collection of software programs that provide storage and retrieval of data. So if you're a DBA or you know your way around Unix or Windows and you go look at a process table, like show me all the processes that are running. You're going to see about 8 processes that are the database instance. I mean, when I say 8 processes, I mean 8 programs. That is the database instance.
So database instance is not a snapshot of database. This is a program that's working on.
It's a set of programs that manage the reading and writing and access to the data. Okay, so that is one definition of instance. In order to not trip into the terminology that you're referring to, which I'm sure on the job that occurs, like, hey, here's an instance of the database. Okay, the more conventional terminology is here's a snapshot of the database.
Okay.
Now, Oracle uses the word snapshot because instance is already taken. We're not going to say here's an instance of the database tables. If you're working with Oracle, you're going to say here's a snapshot.
Okay, so snapshot is different.
Think AirScale.
What's that?
Think AirScale. Snapshot.
Snapshot. All right, so this is trying to get our terminology out here a little bit. The relational database management system provides security and performance features. Performance means tuning. There's about 20 parameters that are really important for the DBA to pay attention to. I had to work with all of those 20-ish. It's not more than 20, it's less than that actually. But 20 is a good ballpark number. It's more than 10 in other words. And from security perspective, we're talking about setting up roles and users. Okay, because you can associate users to roles. And we'll cover that security aspect later on.
What about integrity of the data?
That's where relational database management systems like shine crystal pure.
Okay.
They've got a way, and I can cover this later because it's a little bit more advanced, but they've got a way of taking a segment of, I'll use the word block, taking a block of data that's getting changed on the disk, make a copy of that block, then make the change. So anybody that needs to read that data, that race condition where the data is actually being changed, you get this illusion, literally it's an illusion, that you're reading from the data file, you're actually reading from a copy of the block that's currently being changed.
Okay.
So they have that type of mechanism in play.
That's built then.
Right, that's
Okay.
built in.
That's what I was after.
Yep.
Okay.
So there's, and the term on that is read consistency.
Okay, I've heard that.
Yeah, so read consistency is 100% guaranteed in relational databases. Okay, in the big data arena with Hadoop, if you've poked around in the areas of big data, read consistency is not guaranteed. Okay. It's more lazy updates, whereas the Oracle database is very strict about absolute updates. Every relational database is very strict about absolute updates.
Okay.
So there will be, I think this tool system will be good for different areas. Right?
Yep, different needs.
Yeah,
Exactly.
So they don't care about the strict consistency, just do it fast, then
Mhm.
big deal.
Yep, so, and the idea, think about this just a little bit more, about the value add, because I don't want us to be left with the idea that, oh, relational databases are going to be replaced by Hadoop in the big data arena, because that's not true. And the example there is that Facebook and all of the new tech companies, Facebook, LinkedIn, Netflix, their IT backbone is Hadoop. And Facebook passionately tried to not have a relational database be in their IT infrastructure. And finally, in about 2000, I forget the exact year, somewhere around 2008, 9, 10, 11, somewhere in there, they realized, oh, okay, big data doesn't do everything we need it to, so let's include a relational database in our IT infrastructure within the company.
For the payroll system or HR, they have to use only for user data, they don't care. They can play with big data, I think.
Yeah, so somehow they got around that for a while. And there's ways of getting around it in big data, but it's just clumsy. Okay, so I don't personally ever believe relational databases are going to go away. There's billions and billions of dollars invested into them already. And they do, their relational databases are oriented towards random read-write, is what it's called. I need a small data record somewhere. These puppies, these RDBMSs are the tool to find that little data record somewhere quickly and allow you to make that change and update with perfect consistency of storage and read access. And so that they're extremely well tuned and well architected. Not going to go away anytime quickly.
Dan,
Yeah.
can I get you to come put a password in?
Say again?
I'm trying to do the setup and it's
Oh.
asking for an admin password. Just real quick, so I extracted the files. I'm not getting pictures on this file that you gave me. So, this is where it extracted you, but I can't actually get to that location because when I get down to Oracle here, see how it doesn't have, once I get to student, there's no app data in here. So
Okay.
I can't follow the path it was trying to use.
Okay.
So my question is, do I just run the setup from the download file, which hasn't been extracted, or do I need to find where it's going or extract it to a different location? And I apologize,
Probably a different location.
the pictures are just not coming out
Yeah. So there's a
to tell me where to put it.
Yeah, so there's a PDF. If you go to the, so quick break
So-
here.
Yeah, I'm sorry,
All right,
guys.
so
So this is where we're walking through the developer, and then that's the other one.
so I can see it that way.
That's what I have open.
Right.
And then I also have that MITS 18C user something, but it just basically referred me to the other document. And I don't know why I'm not getting any pictures.
That's the part that's weird.
Yeah.
Okay, where's,
Oh, I didn't download it, I opened it with
Right.
Google Docs.
Google Docs isn't gonna open the PDF clearly. So the PDF should have,
Right click it and run it as administrator and let him, that helps sometimes, especially if it's Windows crap.
so
There's
here it
pictures.
is.
I
Yeah.
was like, where are the pictures?
There's 3 ways to open a PDF in Google Docs, or sorry, in the Google Drive. One way is the way you did it through Google Docs, or you just click on the PDF and it'll basically take control of your current session and present only the PDF. Or you can download it and then pull it up within
I'll just
Acrobat Reader.
download them from.
Okay, so that'll give you at least a better starting point. And
Yes.
then
I'll take a few minutes.
Okay, and then the admin guy, I'll have to figure out how to,
You need an admin password, right?
right, yeah. You might have to do a quick operation.
It's okay, I'm gonna take a quick break. I haven't stopped yet.
Okay. You know, worst case is we might wind up on this other machine here. All right, so client server, we're gonna get into in a moment here. Why don't we just pause, since we paused a little bit. I'll get back to this in about 3 minutes. We'll wait for the ladies to get back.
Hey Dan, can I ask a quick question?
Yeah, go ahead, Josh. Or Joe, sorry.
It's Joe. So between the relational databases, what separates those? Like, you know, is there something that makes Oracle better than the others, or vice versa?
It's more of a market share issue now than anything else. Oracle has always had the high-end business, large companies is their market, and Microsoft SQL Server has always been present within the Windows shops. It's like Comcast is a big Windows-based company. So you're gonna find SQL Server over there more so than Oracle. So a lot of that has to do just with the target market that products are being utilized with it.
Gotcha. So performance-wise, they're all comparable.
They are, yeah, and you'll find that SQL Server has been making inroads into the Oracle space within mid-sized businesses. You know, Oracle's under a lot of pressure from the big data as well, so they both companies had to stay pretty nimble. There's other open source databases out there like Progress. I believe it's how to say that name. And that's used in a big data sense as well as in a relational database sense. With Amazon Web Services being out there, you've got, I believe the name of their relational database system that they use is, if I remember right, it's Redis, R-E-D-E-I-S. So it just kind of depends on what the nature of the cloud is or what the nature of the business is in their history. Now, DB2 is a really, really common database in large corporations that have been around for like 20, 30 years or so. And it has it does not use relational algebra. The relational databases are built on relational algebra, which there is relational calculus, relational algebra, mathematical basis on which the data integrity is built, and we interface that relational calculus, relational algebra using the SQL language. So there's mathematical underpinnings right there. I had an advanced database class in like 1990 or 1991, right around there. So it's a fascinating class. But those are the main differences in terms of databases at the high level.
So Dan, is AWS related to database or do they use?
AWS is a service. It's a collection of services,
Okay.
specifically.
For their database, do they use relational database or like a Hadoop like?
They use both.
Oh,
So it's whatever services you as your company need from Amazon Web Services, that's what you use. Okay. All right, let's keep going with this, and Christine can catch up with us for a moment. All right, so let's look at this client server DBMS. All right, you've got this concept of a session, first of all. Let's look at this. So session is a client program that establishes a session in a connection with a database. So that's a connection that's permanent, or discrete, I should say. Discrete in the sense that it has a definitive start, and then at some point later in time, there's a definitive end to that session. So the client program is connected to the database. All right, the session connection is for one database user. It's never multiple. And the connection is closed when the user disconnects from the database. So we take a look at client A, B, and database server here. All right, let's think about this first one. Client A, this is 1A, sends data requests to the server through the network. 1B, the database server receives data requests from the client. 1C sends data result set to the client. So this term result set, this is fairly common. And so we talk about a result set is the data that gets returned from a database. And then 1D, client A receives a result set from the server. All right, so if you think about a different operation, user provides new data and changes, that's 2A. So 2B, the client sends new data or changes to the server. Take your eyes and follow up to the top here with database server, 2C, whatever that dictated command is to add, delete, or update, that's applied. Okay. So bidirectional across the session, and the same thing exists for client B. Okay. This is where the parallel users, multiple users kicks in. All right, so types of clients. I mean, you got web apps within a browser, you got mobile apps. Nearly every app is going to be interacting with the database. I mean, the really, really, really simple apps don't need a big database on the back end. It might just be a something really simple and very light. Like Derby is the name of a really light, small database that fits well on phones. Okay, so even apps that are on a phone, they usually have some type of database embedded with them, with the code. All right, you've got your IDEs. The IDEs themselves are a client. Okay. You're going to interact with a database, that IDE becomes a client. And then there's some CLIs as well. CLI means command line interface. So hopefully, like from a test environment, the idea of working with a GUI versus a CLI is like bread and butter. Now, if you're at, what was the OS that was using the test platforms you guys from Nokia were working? Using Linux, or you're using?
Mostly Linux.
Yeah. So if so when you're in Linux, you get a shell prompt, usually a $sign. Most people configure their resource file differently. That is a CLI, because you have to literally type the commands in. There's no graphical entry for drag and drop or anything like that. Our various programs can also be clients. So Java programs, they run on any platform. You've got Windows supports ODBC, whereas Java supports JDBC. That's the main takeaway out of these last two bullets from a database-centric perspective. A JDBC connector can exist to relational databases and also to non-relational databases. They have a component in Hadoop called Hive, which gives relational database type behavior and support for SQL. Right, so if there's a JDBC connector, that's what gives the ability for Java to connect with any other database. It doesn't have to be relational on the other end. Okay. Microsoft, similar, only they call it ODBC. All right, so when we take a look at SQL Developer, we're going to see that we've got database connections configured. There's HR user and there's a system user. There's going to be an additional user potentially as well. But that's number one. Number two, if you did just a mouse over, you'll see that on XE system user, it'll say connected or it'll say disconnected. Okay. This is within SQL Developer. The other panel that we're going to be working with is where these tabs occur. So the foreground tab here is intro system user. And that's just an area where we type commands. Okay. So this is going to be our bread and butter place where we work. Okay. And then hidden behind this last, behind this HR user text block, you're gonna see query result tab. So the results of the queries come up on the bottom. So we'll walk through how to work with this a little bit later. All right, so direct database connections, there's two different types. Right, so a direct connection may be such that, and this is the way it would be on your home machine if you download Oracle 18C Quick Start to SQL Developer. You'd have your database and client program directly on your single machine at home. Okay, that's why I've got one of my machines set up at home. Or in the case of the way we're set up in this class, all of our client machines with SQL Developer are connected to a remote database server that's in Schaumburg. Okay, so, and little forewarning, I don't think we'll have any connection issues, but there was about a month where Comcast was like tripping us out. And we kept telling them, you're dropping our connection here. That happened like 4 or 5 times during the day. You know, like I was in some Oracle classes going till 3:30, we get hit by it 4 times. So it's like database connection to database drops. And Comcast is like, yeah, everything's fine, it's your problem. It's your firewall. Something happened on your side of the firewall. They took one of our machines and cabled it so it goes around their firewall and directly connects to their modem. Set up a ping capability. So we had some data to say, it is your problem, fix it. So there's a bunch of pantry around for about a month.
Comcast backhauls horrible.
Yeah, that's what we saw. So
SAT.
So we got through that issue, and in the last like 2 months, I've only seen one network drop while I've been here, so we should be good. Because it shows, even if I'm not doing a programming type class like this, it shows up on our video capture for YouTube, because that network break will cut the video recording. So that's only happened once out of the last like couple months. So I think we're in a good spot with Camcast right now. So if something weird stuff happens, let me know, because it may not be anything you're doing. Maybe that, oh, there was a break. All right, here's an IT commercial setting. Okay, all right, what's the difference between this picture on the bottom and the picture over here?
The 2 servers.
All right, there's 2 servers. The new one in here is called what? Just read it off.
Application.
All right, it's that application server. So what does an application server do?
You can modify the software, modify the database.
Yeah, so that's a good crisp answer. So the software that does the actual modification of data in the database, those software programs are literally in the application server. So when when you and I are working on our mobile phone or working with our web app, some standalone program like Java, we have this impression, not a correct impression, but we have this impression that we're changing data in the database through the client program. That client program is simply telling the application server, oh, here, go make this change, please. Because the application server is actually the one that holds the connection to that database server. There's really a connection from the client on the left, the application server, and that connection these days isn't going to be a fixed, discrete connection necessarily. If people heard of the REST protocol or the REST API, just REST. It's representational state transfer. That's a very, very, very common technology that's used between, and when I say technology, let me replace that. It's a really, really common architecture that's used between the client and the application server. So there is no session. There is no connection. It's just client sends a command, application server receives the command, and the application server is actually the one that's holding a session open to the database server. Okay, so if you want to just put in capital letters above the arrows on the left right here, Joe showed by mouse location. If you want to put REST over here, that's a really common approach. So REST came in with Java. The alternative to REST is called SOAP, S-O-A-P. SOAP came from Microsoft. Java came along and said, you know what? We can use this HTML, hypertext transfer protocol in a really creative way, so we don't even have sessions open. So that this end is going to be REST dominantly, and for some, not all, but for some Microsoft shops, it's going to be SOAP. The application server actually has the connection to your database server. Now this connection might be up, might be used for only a split second or so, or it might be held open for a while. So these are the natures of architecture from an IT perspective.
Dan,
Yeah.
is the application server where you would have your business logic too?
It is a main location where the business logic exists, because you have little functions on your client that are associated with the actual execution of those functions. The actual execution of the functions is on the application server. You just see some type of representation of that function on your client side. So that's where the core logic is going to be located, is on the application server. Okay. Now, to the other point that you mentioned, there's this idea of business rules. So what's an example of a business rule? I think you mentioned that term straight out, Joe, just now.
That can be like maybe not having, well, like for a bank, not allowing somebody to take more money out than they have.
Exactly. It's a business rule is a constraint. So part of business analysis is to identify all these rules or constraints. From a library checkout, it's like the book is going to be overdue after 21 days. So that's a business rule. Your credit card payment will be tagged as late if it's like 7 days beyond the due date. There's a grace period usually there. So whatever the duration of the grace period is, that's a business rule. So all of these business rules can be implemented in the application server. There's nothing wrong with having some of these business rules on the client side and on the application server, and even in some cases, it's perfectly fine to leave some of them on the database server as well. You can have the same rule in all 3 points. Because a big part of this is if you're on the front end with a rule, the customer gets what? Immediate feedback. Okay, as opposed to having to hit the submit button and then go run off and check to the application server. All right, so if the immediate experience is needed, you're going to have business rules that are more on the left-hand side. From a data integrity perspective, if you've got to be absolutely certain the integrity of the data does not get messed up, you're also going to put business rules on the database server. If you have multiple clients or multiple programs coming in, hitting the database server, you as the DBA are like, I don't trust that group that does the software development. We're going to make sure that some of these business rules stay in the database server. There's going to be absolutely no corruption possible on the database side. That's a major concept in the whole space of business analysis and data integrity. All right, relational database table constructs. You got some terminology here, just walking this from the upper left, kind of like clockwise around here. So primary key column in this example contains an employee number. So no other row in this table can have that same number that you see, these numbers being like 10001, so 10,001, 10,002, 10,003, etc. Only one row in that table can have that number. That's what a primary key means. And additionally, there has to be a number there. It can't be empty. Okay, so that primary key means not null. We use this term null to mean not empty. It has to be not null and unique. That's what primary key means. If you want to write that down, it's not null and unique. All right, so that allows us to actually quickly retrieve data because now I've got a unique key that allows me to retrieve a data record. Okay, and if you go across the table here under salary, we have, this is a normal column, it's not a key value. So it's just sal is a normal column, hire date's a normal column, managers a little bit different. I'll get back to that in just a second. The job ID or job type and the email name, these are all the data values. So I use that term explicitly. A cell in a spreadsheet, it contains a data value. Whether that data value is a formula, meaning you've got a derived data value, or whether it's an actual data value. Okay. All right, so foreign key. Where the step number 10 and 20, where do you expect to see the department name?
In another table.
Right, in another table. So this dep number, this is a foreign key. This is the bridge on how to navigate to the correct record in the other table. So you want to think of foreign keys as being your navigation path. You have this foreign key, primary key relationship, and that relationship exists for the purpose of navigating from one table to another table in order to get related information, like the name of the department. All right, so some of y'all got some familiarity with database. Let me mention manager here, and let me throw it out as a question. MGR here. Is MGR a foreign key or not?
There's a relationship because the manager number probably also exists in the employee table. But it's not a key because it can be duplicated.
Right,
And
so,
it obviously can be null.
right, they can be null. Okay, so manager is not operating here as a primary key. It is operating as a foreign key, and it's a foreign key to a data record in the same table. Okay, so the dep number, that's a foreign key off to some other table. When you're doing self-joins, it's called, you're using a foreign key that you got to put quotes around the word foreign, okay? It's like, yeah, it's kind of foreign, but you know, the reality is that this is the manager data value here is the ID of an employee in that table. See, we just call that a self-join when you actually do the joining on that. Join across tables, you can self-join if you've got functionally the foreign key of the
It's right,
primary.
okay.
So if any column, can any column be a foreign key other than the primary key column?
Yeah, a foreign key will always be a primary key, that data value from that same table or from a different table. Because the purpose is to be able to navigate. You navigate by connecting these foreign keys and primary keys. All right, so let's walk through our terminology here. So table is a storage area. So everybody has seen that enough. It's like, okay, got it. A row is a set of data values for a specific data record. Column, key thing with a column is its name and a data type. And you're going to see in Oracle that we've got data types such as varchar 2. This is variable character 2. So it's not varchar, it's varchar 2 because Oracle changed their internal structure of how they store these variables at some point. I don't know if they changed it like 15 years ago or 10 years ago or whatever. My recollection is more like 15 years ago, but it was a while ago. So these are variable length. They can be, 2,000 characters long or 1 character long. You've got integer, which Oracle refers to as just number. And when I say number or varchar 2, that's part of SQL. standard. Now there's other attributes, name, ID, etc. All right, so you've got a name, you got a data type. So and that concept is basic programming. Anybody that's had to do any kind of programming, it's like, oh, if I create a variable, I gotta have a data type. Same thing. If I create a column, I gotta have a data type. Primary key we went through, foreign key we went through just now. This is just the verbiage that goes with what I said earlier. The foreign key definition that's in here is oriented strictly towards table-to-table relationship, as opposed to what I said with the self-join, where managers actually serves as the foreign key inside that same table. So if you want to add that a little caveat of self-join onto this foreign key definition, you can go ahead and do that. All right, so terminology. What have we covered? We've got client, database server, connection, and session. All right, so what is a database server?
The server that hosts the database, where the database is actually stored.
Okay, so in that and I throw this question out because there's two definitions. So Christine's definition is exactly correct, and then there's the other one. So you're focused on in Christine's answer, she focused on the hardware server, or it could be a virtual server these days, that contains the database programs. So that is one very common term as well. So if you're on a job in an IT shop or whatever, the database server, and this is why I throw this term up here, you're on the job, you're going to hear very often that, oh, there's the database server, meaning the database instance. Okay, that's the second definition, because on the job, it's really, really common to interchange the term database server and database instance when we're talking about the software programs that are the database, or that manage the reading and writing to that database. Right, so you just keep in mind that there are two different definitions, and both of them are valid. Both of them are heavily used. All right, client is, what are some examples of client then?
It's the users.
Say again?
Users?
Let's
The user.
see, uses be a little bit more specific. So that I would say that's true, that it's really generic, so I centered in a little bit more.
Or PC, some of PC.
Yeah, so if you want to get down to client, it's specifically going to be a program running on the PC.
Right.
Okay, so get it down to that program level. It's some type of software running on the PC or whatever is in front of us or on our mobile phone. Okay. And then what's the relationship or how would you define connection and session? We've talked about that a little bit, but as you can guess, this is kind of the review slide here. Just make sure we got some of our terminology on the same page here. All right, so what's the same or different between connection and session?
Session is when you start it, and then when you stop it, when you want to start the session, and then you want to stop the session on your program.
Mm-hmm.
And then the connection is the network from your device into
Right.
database.
Right. So these two are they're almost like close cousins or siblings. And the session literally, for Oracle, for example, there literally will be something called a session ID, and they also call it a serial number in Oracle. So your session ID plus serial number, and the serial number is random generation that's unique per connection. But that pair of values identifies this unique client. And then that pipe, so to speak, through which the session exists is the connection. So the idea of session is very, very specific. And there's one specific client that has control of this connection. Now, connection is a very broad term. It doesn't necessarily imply a unique client. All right, so table, column, data row, data value, we walked through that. Primary key, foreign key, walked through that. All right, so this is the terminology, And what we're going to move into is getting acquainted with SQL Developer in terms of opening a connection to the database, which some of you have done already, but we'll take and look under the hood really briefly so we can see what's involved with that, and exploring a couple tables and starting a new SQL file, text file. And at this point, we're going to get started using SQL. All right, so we'll have to take a break at this point. Let's see. Because I've got to make sure everybody has SQL Developer available. All right, so we're at 12:15 here. Let's take a break until about 5:02. And that'll be enough to find out the obstacle that Christine's going to hit on her machine. You might have to jump over to a different machine, but we'll work out those logistics as we move ahead here. Okay. So then, Joe, are you available to be typing in commands and using SQL Developer from home over the next hour?
No, I'm actually watching this on my iPad. I'm not actually at my house.
Okay, just wanted to double check. So we'll make sure that there's a SQL Developer session available for you next time, not on Monday. All right, so
Okay.
with that, I'm gonna end this particular recording. I'll send out a new link that you can join on to, Joe.
Okay.
Okay. So take a break for a little bit and just get final logistics of access set up here.